Alright guys, let's do a quick review on your homework from parent functions where you have to go back and fill in the domain and range. We call from algebra that domain is the set of all possible x-coordinates of all of the points on your graph. So if I look at the points on my graph here, for my linear function, looks like all of these points covers any possible x's that I can pick, right? So my domain in this case is from negative infinity to infinity. X can be any real number. And then for my range, now again, looking at all of these points on the line, the range of all of the possible y-coordinates of every point on your graph. So all of these points have a y-coordinate of 3 because my equation is y equals 3. So for this particular example, my range is just the value 3, and I use the brackets to represent the set of all numbers that includes, in this case, just 3. Okay, next one. This one's a little bit tricky. I have the steps, and just remember that even though I didn't fill out the whole graph, that it does fill up the whole graph, so I could just keep going. And so if I were to keep going, notice that again, every x value is covered by a point on my graph, because when x is 0, my point's right here, x is 0.5 right here, x is 0.6 right here, and even though x equals 1 is not covered down here, it is covered up here. So every single possible x value is covered by a point on my graph. Domain is negative infinity to infinity again, all real numbers. The range, however, is slightly different because I don't have a point on my graph that has a y value of, let's say, 2.5, right? I also don't have a point that has a y value of 5.2. And so if you notice, all of the y values on this segment is at 0. All of the y values of the points on this segment is at 1. All of the y values of the points on this segment is at 2. And so my range is all the set of all integers. And the symbol for that looks like this. It's a little z, which represents the set of all integers. And if you wanted to list them, instead of writing that symbol, you could say the set of all numbers that includes, let's start with dot 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 because it continues, -2, -1, 0, 1, 2, dot dot dot, etc. So just all integers. Okay, the line is nice and easy. Again, it looks like every x value that I can possibly imagine is covered by a point on this line. So negative infinity to infinity, because there's no gap from left to right. Every x value is covered. And then for my range, my graph keeps going down and up, and every single y value is covered by a point on my graph. So range is also negative infinity to infinity. Okay, absolute value, reading my graph from left to right, looks like it keeps going up and to the left and up and to the right. So from left to right, every x value is covered, negative infinity to infinity for my domain. And then my range is slightly different because for this absolute value function, it looks like there are no points that has on my graph that has a negative y coordinate. And so the smallest y value for any given point on my graph is 0. And so my range in this case goes from 0, including 0. Notice I'm using a closed bracket, that means including 0, any number from 0 all the way up to infinity. And the arrows keeps going up, so I know it's going to continue on forever. Any number between 0 and infinity, including 0, but not including infinity. And then for my parabola, again, you want to assume the arrows that as my parabola goes up, it's going to also get wider. So my domain is from negative infinity to infinity. And then again, I don't have any points on my graph that has negative y values. So the range goes from 0, including 0, up to infinity. The square root function. Now there's a restriction here because I have the square root, we said we can't input x values that are negative, otherwise it doesn't give me a real answer. And so the smallest x value that I can input in is 0. So my domain goes from 0 to infinity, and you can look at that, you can identify that domain by looking at the graph or the equation, because just by looking at the equation you should know that 0 is the smallest number I can put in, that I can start with. And since 0 is the smallest value that I can input into the function, the square root of 0 is 0. 0 is also the smallest output that I'm going to get, and that's why my range is also from 0 to infinity. Smallest y is 0, and it goes up to infinity. Okay, cubic function, assuming that using the arrows, my graph is going to keep going down and up, down on the left, up on the right, and as it keeps going up and down, it's also going to get wider. So my domain is again from negative infinity to infinity. Every x value is going to be covered. And then my range is also negative infinity to infinity. Now, without looking at the graph, we can also again identify by looking at the equation, because my function rule is I'm going to take any x value that I'm going to pick and I'm going to cube it. And there's no restrictions for what you can cube, right? You can cube any number, decimals, fractions, positive, negatives. You can multiply it by itself 3 times and get a valid output. And so that's why there's no restrictions like the square root for the cubic. And so domain and range are both all real numbers from negative infinity to infinity using interval notation. Okay, the last but not least, the reciprocal or rational function. That's the fraction, and because we have a fraction, we do have some restrictions. Normally, your domain for most functions is going to be negative infinity to infinity, unless there is some restrictions in the function, like the square root, no negative x's, right? Now, because I have a fraction with x in the denominator, we said can't have a 0 in the denominator, so x can be any number between negative infinity to infinity except 0. Now, how do we write that in interval notation? We're just going to create a little gap. We're going to say x, my domain, x can be any number between negative infinity and 0, but not including 0. So any number in between. And then I'm going to put this little u, which is the union symbol that represents or. X could also be any number between 0 and infinity, again, not including 0. So basically taking this, which is all real numbers, and just creating a little gap in the middle because I know that x cannot be 0. And then the range, again, is from negative infinity to 0. Y cannot be 0, because in order for my y to be equal to 0, the numerator would have to be 0, but my numerator is always 1. So range is also negative infinity to 0 and from 0 to infinity. Okay, those are the domain and range. Check your work. And then lastly, we're just going to go back quickly and do a quick check on your transformations. A couple of the graphs I asked you to graph on Desmos, graph a transform function on Desmos, or using your graphing calculator, and kind of compare that to the original parent function and see what the transformations were. How was this function different or transformed from the original parent function that you graphed above? So for the absolute value, you might notice that, when I graph this new function, it looks like I took my original parent function and I moved it 3 units up. And I've also, your v should have gotten taller and skinnier. There should also have been a vertical stretch by a scale factor of 2. We're going to be reviewing transformations in the next few sections, so I wanted to give you a sneak review, a sneak peek into it. Okay, and then for the square root function, this is my parent function. How does this new function how is this new function transformed from my parent function, you might notice that I'm taking the graph of the parent function and it shifted down 5 if you graphed it. And then that negative in the front gave it a reflection. You should have observed a flip reflection over the x-axis. And then for the cubic parent function, new function, graphing it, what kind of observations did you observe? You should have observed that the graph is moved 2 spaces up, and also the negative, again, the negative is always a reflection. So a reflection in this case over the y-axis. And I believe those are all of the transformations.